Hi everyone, today I'm going to show Bhaskara's formula and why it was invented. I think that's the way it's pronounced, Bhaskara, Bhaskara, I don't know. But anyway, let me just, okay. So, let me situate myself in here. You see these points here and here? Well, they're the zeros of the parabola, okay? They're the place where the parabola crosses the x-axis. And Bhaskara's formula is to find these two zeros. Anyway, yeah, we're just talking about some real numbers here, real roots. These are called the zeros or the roots of the equation. And Bhaskara's formula, well, what defines a parabola? Let me just explain to you guys the function of a parabola. This is the function of a parabola right here. Let me choose another color. That's the function of a parabola right here, okay? So you have ax squared plus bx plus c equals y. And the zeros are the values of x for which this function is going to be 0, for which y is going to be 0, okay? So to find the zeros, you gotta equate this y here equal to 0. So ax squared plus bx plus c equals 0. Okay, now if you try to find this the conventional way, like let's isolate all the x terms on this side, and I'm gonna pass the c term, the independent term, to the other side, and I'm also gonna factor out these x's. So you see here you have x, I'm going to factor x out, ax plus b equals minus c, right? Well, you got a problem here because if you pass this x right here to the other side dividing, you're still going to be left with some x in here. And if you pass this one to the other side dividing, then you're still going to be left with an x here. The problem is that you can't seem to be able to isolate the x. So none of this is going to work, okay? And we got to try something else. What we have to try is to transform the left side of the equation here into a perfect square, perfect binomial, right? A perfect square is this, x plus y squared. This is a perfect square. And we got to try to make something like this on this left side right here. So what Bhaskara found out is that if the coefficient, this a and b and c, okay, are just coefficients, and you want the coefficient of x squared to be 1 to make things easier. So you start dividing the whole thing by a, all right? Ax squared divided by a, x squared, plus bx divided by a plus c divided by a equals 0, right? And now you're gonna copy this whole thing again, x squared plus bx divided by a plus c divided by a. And now you gotta add something here. How do you transform this into a perfect square? Well, you gotta get the coefficient, that the x coefficient, not the x squared coefficient, but the x coefficient, and you have to divide it by 2 and square it. So b divided by a divided by 2 is divided by 2a. And when you square this whole thing, okay, you're left with b squared divided by 4a squared. So b squared divided by 4a squared is what you have to add in here. B squared divided by 4a squared. But if you just do this, the problem is that you're adding something to the left side. If you're adding, you got to subtract, so you're not going to change the value because the whole thing still has to be equal to 0. So you just added this, you have to subtract it. Okay, b squared over 4a squared equals 0. Good. Now you're going to get this term, and this term, and you're going to make it into a perfect square like this. X plus b divided by 2a squared. Now, I just want to open a parenthesis here. Does this equal to these, does this perfect square here equal to these three terms? Yes, it does. You see, if you try to expand this, you got x squared plus 2x b over 2a plus b squared over 4a squared, and you simplify these here. So you got x squared here, in here you have bx divided by a, and you have b squared over 4a squared, b squared over 4a squared. So yes, this square binomial here represents all these three terms, okay? So all you gotta do is to do equals, and I'm gonna pass these independent terms to the other side of the equation. So it'll be b squared over 4a squared minus c over a, okay? Now I want to transform this thing here, this a, I want to join these two fractions. How do I do that? I got to make the denominator equal. Now you got an a here, and I want to transform it into a 4a squared. So what do? I just multiply it by 4a. So I'm just going to put a square here, and I'm going to put a 4 here, okay? And since I did it to the bottom, to the denominator, I got to do it to the numerator. So you got a 4a in here. Okay, good. Now, I'm going to take the square of both sides, okay? Taking the square of both sides, I can make this thing here disappear, this 2 disappear. And here, I'm going to do the square root. And when you take the square root, it's got to be plus or minus, okay? So on this side is going to be x plus b divided by 2a equals plus or minus. When you have the square root of a fraction, you can separate the square root of the numerator by from the square root of the denominator, okay? You can separate one from the other. So you can take the square root of b squared minus 4ac divided by the square root of 4a squared. You got to remember that I just joined these two because it's the same numerator now. It's the same denominator now, right? 4a squared here and 4a squared here. So it's just b squared minus 4ac divided by 4a squared. So what is the square root of 4a squared? It's 2a, right? So now all I gotta do is to pass this thing here to the other side, and that's what I'm gonna do over here, okay? It's gonna be x equals minus b divided by 2a plus or minus square root of, sometimes people call this expression b squared minus 4ac the delta. So I'm just going to call this delta over 2a. And there you go. This is Bhaskara's formula. X equals minus b minus plus or minus square root of delta divided by 2a. There you go.